Welcome. Today's lesson is on the cation exchange capacity, its definition, and why is it so important. The components that make up soil are air and water, plus the minerals that are left here on your screen, such as sand, which is the largest of the components, silt, which is more mid-range, and clay, which is the smallest. It has the largest amount of area per volume. It also has a negative charge on it. And let's not forget this last one, organic material. This organic matter, or sometimes called humus, is a mixture of decomposing as well as living materials. All of these make up the texture, color, and storage capacity of our soil matrix. And what we're going to be talking about is the important part that organic matter and clay have in the storage of nutrients in our soils. In this illustration, we have some gray blobs that represent soil particles that have negative charges. In other words, they are ions. While nutrients such as hydrogen, calcium, magnesium, sodium, aluminum, potassium, and ammonia are cations that are positive in charge. In order for plants to take up nutrients, which are cations, they must attach themselves to the anions that are on the soil particles. If they fail to attach themselves, they'll get washed away into the soil and quite possibly into drinking water. To give you a look of what it might look like, if these potassium cations are not attached to anions on the soil, this is basically what happens. They get bypassed, washed away from the soil particles, and that's where they need to be for plants to be able to grow. Now, in a normal situation, basically what happens as the cations make their way through the soil matrix, they will start attaching themselves on those negative ions that are on the soil particles. Those little dashes there are the anions. If you take a look at them, they basically will attach one to one. What I mean by that, for instance, if we looked at the green hydrogen there, H plus, the cation or the plus charge will pair up or attach itself to the soil particle because it has one of the anions available for it to attach to. Now, if you take a look at the calcium down below, the Ca plus 2 charges, the cations, two of them, will attach themselves one to one ion and one to another ion. The more cations that are attached to the anions, the harder it is for them to be removed. Now, let's take a look at what happens as these particular cations are basically transferring those cations to the soil particles. Normally what you have is some cations still attached to the soil particles. But for instance, let's say we're going to be fertilizing some of our crops and we're going to be using potassium chloride, for instance. It has to have some kind of, has to be traveling some kind of solution. Typically it's water. And when that takes place, then some of these cations will displace and released, and it looks something like this. As they are replacing them, they're also taking over some of those sites, those ionic sites that are on the soil particle. For instance, on calcium, up at the top, you notice it's taking over basically two of those anions. And then potassium, near the middle of the screen, you'll notice the two Ks, they have one basically cation per element, and it's attaching itself to some open anions. So what have we learned? What was the definition we can come away with when we're talking about a cation exchange capacity, CEC, is the ability of the soil, and it's mostly the clay and organic matter particles that absorb the ions on its surface or edges. The ability to be able to not only attach it, but also to store it as well. In other words, the more negative charges the soil particles has, the more nutrients it will be able to hold. So the more negative it is, the more nutrients it can store. Then also, the higher the surface area means more capacity, thus higher CEC. So like for instance in clay, which has a high amount of surface area per unit of volume, it can actually hold quite a bit. Thus, those type of soils, some with some clay in them, are going to have a higher capacity or a higher CEC. So, what does that mean? Well, does it mean that soils with low CECs will have lower yields and prevent it from actually producing enough food? Well, yes and no. It kind of depends on your ability as a farmer or manager or grower to be able to slowly let out certain chemicals at certain times. For instance, most crops only need small amounts of nutrients at any one time. And if you have your soils tested on a regular basis, you can still produce high yields and a top quality crop as well. So you can make them actually hold their materials, have them hold their nutrients. Now, what does that mean on the day-to-day basis? The first thing is, this is a soil report, and you need to make sure you include a CEC report with it. If you'll notice that the area that I circle says 19.1, 24.7, 13.1, 12.1. Why is CEC so important? Number one, it allows you to be able to determine what or how much nitrogen you can apply. All of these numbers here are milliequivalents per 100 grams, which is fine and dandy, but the thing is, it's really a small measurement. We need larger measurements to understand what we have in our field. To do that, if you take that number and multiply it by 10, you change the units from milliequivalents per 100 grams to pounds of nitrogen per acre. And so when you multiply each one of those, it will give you the amount of nitrogen, clay, water, and organic matter. In this case, what we have here, we take 13.1 and multiply it by 10, you'll get 131 pounds of nitrogen per acre. That can be applied. So that's what that means. Now, if, for instance, if you had already 20 pounds of nitrogen in your field, according to the report you just got, then you only need to apply about 111 pounds per acre. So those numbers there are really important for you because it, number one, tells you the amount that is stored, and number two is how much you can apply to it at any one time. I hope that's helped you understand the importance and definition of the ECC. If you like this content, please give me a like and don't forget to subscribe. So thank you very much, and we'll see you in the lab. Thanks. Bye.